All right. So next we're going to talk about is spectrums. And spectrums are when you split the light into its component colors. All right. So the first type we're going to talk about is something that's very familiar, a continuous spectrum. You take white light. One way you can cause this to happen is you put it through a prism, and you get all of the colors. And you may be familiar with the acronym Roy G. Biv: red, orange, yellow, green, blue, indigo, and violet. And there are no gaps. So it looks like a rainbow. So this, okay, is a continuous spectrum. Now, there are two other spectrums to talk about. The first one is called a bright line spectrum, or an emission spectrum. And the way an emission spectrum is made is you put heat into a gas. So you have a hot gas. It's going to emit light. If I take that light and put it through a prism, now instead of a whole rainbow, I only get a few very specific colors. Okay, so it's emission spectrum because the gas is emitting the light. Okay, and it's called a bright line spectrum because see down here, you just get a few very distinct bright lines of color. You don't get that whole rainbow all spread out. And one thing we're going to say here is that each element has its own unique spectrum. Which can be used to identify the elements. Which is how they find out what elements are in specific stars. If they see the particular lines for that element in the light coming from the star, they know that element is in the star. And the last type of spectrum we're going to talk about is called a dark line or absorption spectrum. And therefore, when you take white light and shine it into a cool gas, the gas absorbs only a few specific colors. And it turns out it's going to absorb, when it's cool, it's going to absorb the same colors it emits when it's hot. So on the previous page, we had hydrogen, and hydrogen emits kind of red and a greenish color and a purple. It's going to absorb those same colors. And it's going to leave dark lines in the spectrum. So if I took this white light and just put it through a prism, without the cool gas in the way, I would get a continuous spectrum, all the colors of the rainbow. But now it's going to absorb a few. So you get a rainbow, but with dark lines where the colors are missing. And that's going to look like this down here. Now, here is an example of how we would use it. And it's really straightforward. We just want to see what elements are in this star. So I'm comparing with 3 known elements, and it's just a matching game. I see these three here, they match up with those. These two match up here. This matches here, and this matches here. So I can tell that I have hydrogen and helium are in the star. But argon's not, because the star doesn't have the lines from argon.